we are given an integral, the integral of the square root of 1 plus sine squared of x minus 1 times sine of x minus 1 times cosine of x minus 1 dx. Now we're going to perform the sequences of substitutions to evaluate the integral. A says that we should perform the substitution using u equals x minus 1. The derivative of du would be 1 dx. So if we rewrite the integral using this substitution, we would have the integral of 1 plus sine squared of u, since u is x minus 1, times sine of u times cosine of u. Next, we would perform the substitution v equals sine of u. So then we would have, if we substituted v, the integral of 1 plus v squared v times dv, because dv equals cosine of u, which is the derivative of sine u. Next, we will perform the substitution w equals 1 plus v squared. The derivative of w is simply 2v dv. If we perform the substitution, we would have the integral 1/2 square root of w. Part B says to perform the substitution u equals sine of x minus 1. If u equals sine of x minus 1, du would be cosine of x minus 1 times what's inside the parentheses, which is just 1, dx. If we rewrite the integral using this substitution, we would get the square root of 1 plus u squared u du. Next, we will perform the substitution v equals 1 plus u squared. dv would equal 2u du. Using this substitution, we would have 1/2 square root of v dv. Using substitutions from part A and part B, we can evaluate the integral. So for part A, if we go back up here, we would evaluate the beginning integral as 1/3 1 plus sine squared of x minus 1 to the 3/2 plus c. And we get that from using all of the substitutions. For part B, we would also get the same answer. Using the substitutions given. For part C, we would perform the substitution u equals 1 plus sine squared x minus 1. The derivative of u, 2 sine of x minus 1 times cosine of x minus 1 times the derivative of what's inside the parentheses, which is just 1, all times dx. We can also evaluate the integral using the substitution from part C. And we would get the same thing as we got in part A in part B.